Hello students, good morning, and today we are going to discuss, that is chapter 6, work energy power part 2. And in this we had already discussed about the definition of work and work done by the constant force. In that work done by the constant force, we had discussed that if the displacement of the object is along the direction of the applied force or any component of the applied force, then the work is said to be done on the object. Now, on the basis of the angle subtended by the force and the displacement, we will classify the work in three categories, that is positive work done, negative work done, and zero work done. So, on the basis of angle subtended by the force on a given object, the work done is classified as first positive work done, negative work done, and third one is zero work done. Now dear students, we will discuss positive work done, negative work done, and zero work done one by one. So let us discuss about the positive work done. Let us discuss about the first thing, that is positive work done. The work done is said to be positive when the applied force has the component along the direction of the displacement. When the applied force has the component along the direction of displacement. When the applied force has the component along the direction of the displacement. So look at the case. Suppose this is the object and the force is applied in this direction. Due to the applied force, the body displaces in this direction and the force makes an angle theta with the displacement. It means to say that the component of force, that is F cos theta, has the F cos theta, which is the component of the force, has the direction along the direction of the displacement. Means, what can you say about the angle? This angle theta either less than equal to theta, either less than equal to 0 or greater than 0, but less than equal to 90 degrees, because the theta varies from this position up to this position, up to not 90 degree but up to to this position, and in all situations the force has the component along the direction of the displacement. So in this situation, what you can see that theta is equal to acute angle. Theta is equal to acute angle. And as you know that for cos theta, what is the case for cos theta? If you draw the graph of the cos theta, then what you will observe? You will observe that the cos theta graph goes like this. That is the value of theta, cos theta, and here the value of theta and cos theta. This is maximum value of cos theta. So if theta is equal to 0 degree, then cos 0 has its maximum value, that is 1. At theta is equal to 90 degree, the value of cos 90 is equal to 0. At theta is equal to 270 degree, it is -1. At theta is equal to 180 degree, again it becomes 0. And in this way, the cos theta, so we had told that 0 is less than equal to theta is less than 90 degree. Means theta will lie between 0 degree to 90 degree. Means the value of theta is acute angle. And if the value of theta is acute angle, then what you are getting the value of cos theta? Maximum value of cos theta is 1, and after that it goes on decreasing and it becomes 0 at theta is equal to 90 degree. So it is the acute angle and its value is always cos theta is always positive. Cos theta is always positive. For this case, when component of force is along the direction of the displacement, then always cos theta is positive, and this is the case of positive work done. Now we will clear it by certain examples. Look at certain examples. We will discuss about certain examples. Examples of positive work done. Examples of positive work done. And the first example of the positive work done, when this is a block and a card, a bulldog card, suppose this is a card and this is a block. Means if the block is pushed by the card, then what you are observing, the angle between here, it is the applied force. This is the applied force, and this is the direction of displacement of the block. This is the applied force, and this is the direction of the displacement of the block. So here, in this case, the work done is positive. When a card pulls and when the card moves and the second thing, if someone is lifting, suppose this is the weight, this is the mass, and its weight is mg is the weight, and any force F is applied on this weight, and this force is lifting this weight. This force is lifting this weight. If this force is lifting this weight, then what you are seeing that, what you are observing that the force, so since this force is lifting this weight, means the applied force means the body displaces in this direction. The body displaces in this direction, that is in vertical direction. And as the body is displacing itself in the vertical direction, means the angle between the force and the displacement is 0 degree. Angle between force and displacement is 0 degree, or you can say that the component of force is along the direction of the displacement. The component of force is along the direction of the displacement, and in this case also work done is positive. Work done is positive. The third example. Suppose here there is a spring, and you had loaded this spring with mass m. Then the weight is mg in the downward direction, and the spring is stretching in downward direction. And the spring is stretching in the downward direction, means whatever the force acting on the spring and the stretching or elongation of the spring in the same direction, means the applied force and the displacement are in the same direction. So here also work done is positive. Here also the work done is positive. So this is all about the positive work done. Means in nutshell you can say that the work is said to be positive when the displacement and the component of the force is along the same direction. Now we will discuss about the negative work. Now dear students, the second case we will discuss, that is negative work done. And negative work done says that if the applied force has a component opposite to the direction of displacement, and if this case happens, look at here, there is a case. Suppose the body is displacing in this direction. This is the direction of the displacement, and the force is acting in this direction. Then suppose this angle is theta, then the component of the force F cos theta, which is acting opposite to the direction of the displacement. Now look here, this angle theta is, in this case, this angle theta is greater than 90 degree but less than 180 degree. Means if this condition is going to happen, means if the angle between the applied force and the displacement of the object lies between 90 degree to 180 degree. 90 degree not equal to 90 degree but greater than 90 degree and less than 180 degree. In this case, the work is said to be done is negative. As I have told you about the graph, this is 90 and this is 90 to 180. At 180 it is going to be 0, at 90 it is going to be 0. And in between 90 and 180, whatever the value of cos theta, all these values are, this is cos theta. and along this is the value of theta, that is 0 degree, that is 90 degree, and that is 180 degree. So look at here, the value of theta is, this is 270. 0 degree, 90 degree, 180 degree, and 270. So at 270 degree it is equal to 2. So the value of cos theta is negative. The value of cos theta is negative between 0 to 180 degree. Between 0 to 180 degree. Now look at here. Here also, if it is greater than 180 degree, then also a component is opposite to the direction of displacement. Suppose this angle is greater than 180 degree, then also the component of the force is opposite to the direction of the displacement, and in that case also the work done is negative. Means to say that the value of work done depends totally upon the value of the cos theta or the angle theta with which the force is going to make with the displacement of the object. So in this case theta is equal to obtuse. In this case also theta is equal to obtuse, and in this case the work done is negative. The work done is said to be negative. In this case work done by the force is said to be negative. This is the negative one. Now we will discuss about certain cases, certain examples of the negative work done. So dear students, the first example of negative work done is that you are trying to get, suppose a vehicle, this is a vehicle, and this vehicle is moving in this direction. This is the direction of displacement of the vehicle, and suddenly you apply a brake on this vehicle, then the retarding force F retarding force is opposite to the direction of the displacement. When brake is applied, on the vehicle, then work done by retarding force, work done by retarding force is negative work done. This work done is negative work done. The second example is, suppose on a rough surface you are dragging a mass by force F force, dragging force. Then if on a rough surface a dragging force is applied on the object, then to counterpart this dragging force, a force parallel to this applied force acts on the object, and this is called as the frictional force. So work done by frictional force, frictional force is negative. Work done by the frictional force is negative. Another example is, third example, suppose this is an object and you you are lifting the object by force F. You are lifting the object by force F. Then, due to its weight, a gravitational force mg, due to its weight acts in the downward direction. So, in this case, the work done by the gravitational force. In this case, work done by gravitational work done by the gravitational force. This work done is also a negative. This work done is also a negative work. So this is about the negative work done along with examples. Now we will discuss about the zero work done. So now dear students, the third case is zero work. So zero work done is said to be done on an object when the object displaces itself perpendicular to the applied force. Perpendicular to the applied force. When the object displaces itself perpendicular to the applied force. For example, suppose a force F is acting on the object in this direction, that is normal or perpendicular direction, and the displacement of the object in this direction. Then the angle theta between the applied force and the displacement is 90 degrees. This angle theta is equal to 90 degrees, that is at right angle. And in this case, W is equal to Fs cos theta. And you had seen that the nature of the graph, that is 0 degree, 90 degree, 180 degree and 270 degree. Means at 90 degree when theta is the value of cos theta is equal to the value of cos 90 degree is equal to cos 90 degree is equal to 0. Cos 90 degree is equal to 0. So we can write it as F as cos 90 degree, and in this case the work done is 0. And this is the case of zero work done. So we will discuss certain examples regarding the zero work done. Examples regarding the zero work done. The first example is that suppose there is an object and if due to the object placed on the surface, there is the weight mg or normal reaction n, and the body displaces in this direction. So work done by its weight mg or normal reaction R is Z. So it is the case of zero work done because both the angles are 90 degree. 90 degree. So W is equal to Fs cos 90 degree and the work done is G. Now another example. Look at another example. Second example. Suppose a body is moving in a circular path. The body is moving in a circular path. This is the center, and so at each and every point, the centripetal force is always acting in this direction towards the center. At each and every point, the body is displacing tangentially. At each and every point, the body is displacing tangentially. At each point, the body is displacing tangentially. And this angle, force and displacement, always this angle is 90 degree. The force and displacement, always this angle is 90 degree. So here, theta is equal to 90 degree. So work done by the centripetal force, work done by the centripetal force, that is Fc is equal to always G. This is always G. The third example is that suppose there is a case of simple pendulum. The simple pendulum, and look at here, the simple pendulum is displacing in this direction, and the tension T developed in the string, is responsible. This tension T developed in the string is responsible to move the pendulum into to and fro motion. So this angle at each and every point of the motion, the angle between the tension and the displacement is 90 degree. The angle between the tension and the string is 90 degree. But if it comes here, then there is no displacement. But where throughout the path from its mean position to extreme position, wherever the ball is displacing by the effect of the tension developed on the string, the angle between the tension and the displacement is 90 degree, and angle between tension in the string and displacement is 90 degree. So we can say that work done by the tension is G. That is the case of zero work done. That is the work done by the tension in the spring. In case of simple pendulum is zero. So dear students, this is all about the different type of work done, that is positive, negative and zero work done, with different examples I had explained, and I hope that you met the clear concept regarding these things by watching the video. Now we will discuss certain numericals based on these. Now dear students, look at the numerical. A long roller has been pushed by a gardener. There is a surface, and here there is the lawn roller, and it is pushed by the gardener through a distance of this lawn roller. The lawn roller is pushed by a distance of 30 meters. It is pushed by a distance of 30 meters. What will be the work done by him if he applies a force of 30 kg in the direction in fact this force is inclined at an angle of 60 degree. This force is applied at an angle of 60 degree. Z is equal to very equal to force is given as 30 kilogram weight. That is the gravitational limit. That is the gravitational limit of force, and you can write it as 30 into 10 Newton. That is 300 Newton. The force is applied. That is equal to 300 Newton, and theta is equal to 60 degree. Clear? And displacement S is given. That is equal to 30 meter. So W is equal to F S cos 60 degree, and F is 300 Newton into 30 meter into cos 60 degree, and it is equal to 300 into 30 into 1 by 2, that is 50. That is equal to 4,500 Joule. This much amount of work is being done on the object when the force F is applied at an angle of 60 degree with the displacement of the lawn roller. Now look at the next question. Now dear students, look at the next figure. A pulley is holding a bag by applying a force of 50 Newton. Suppose here there is a pulley and he had holded a bag. He applies the weight of the bag is downward and he applies the force of 50 Newton over this bag. He moves in the forward direction and covers the horizontal distance of 8 meters, and he covers the S is equal to 8 meters in horizontal direction. Then climbs up and covers the vertical distance. After that, he climbs up. After moving 8 meters, he climbs up and moves a distance of 10 meters. Then what will be the total? So it is given that force is equal to 18 meters. The distance S1 is the horizontal distance and it is 8 meters, and S2 is the vertical distance. It is equal to 10 meters. Now look at here as well. There are two cases. In first case, the force and the displacement are perpendicular to each other. First case, force and displacement are perpendicular to each other. So here theta is equal to 90. So the first work done, W1 is equal to F S1 cos theta, that is equal to 18 meter into force is 18 meter, 18 Newton into 8 meter, 18 Newton into 8 meter. This force theta is equal to here 90 degree, cos 90 degree, cos 90 degree, and as you know that the value of cos 90 degree is equal to 0. So the first work done is 0. Second, he climbs up with 10 meters, means displacement are in the same direction. So force in second case, force and displacement are in same direction. Theta is equal to 0 degree. Theta is equal to 0 degree. So W2 is equal to F S2 cos 0 degree, and it is equal to 18 Newton into S2 10 meter cos 0 degree, that is 180 Newton meter, that is 180 means in this case the work is said to be done because the force and displacement are in the same direction and the work done is 180 joule. And in the first case, so total work done W is equal to W1 plus W2 and that is equal to 0 plus 180 joule, that is 180 joule. 180 joule is the net work done. So dear students, this is all about the today's video. Now tomorrow we will discuss about the work done by the variable force. So thank you students, have a nice day, take care.